our next presentation would be the titled Preliminary Observations on the AVHR Mears version 5 daily NDVI data for the assessment of vegetation climate dynamics in the Juba Shabelle watershed of East Africa. And presentation is going to be given by the team represented by Jesus Pozo, Andrea Miranda, Sergey Nabatov, Aletia Kielbasa, Abdus Samad, and Benedetta Francesconi. I hope I did an okay job for the names. You can start sharing your screen.
Great, thank you. And yes, you did a great job. Let me also share my video so you can see who's talking. Okay. Hi, everyone. Thank you for that introduction. Okay, awesome. So we are the Sarophaganics popping forte. Ooh, I said it. I love our name, but it's sometimes hard to pronounce. And we're going to be looking at, I know there's a slight title change, so I apologize for that, but we're going to be looking at exploring long-term climatological patterns of cloud coverage and NDVI in East Africa, specifically the Juba Shabelle river basins, using NOAA's surface reflectance climate data record to do so. So before we really get into the work we've been doing over the past several months, just a couple of acknowledgements. First, we like to acknowledge the Forte team. We've had a lot of fun working together and coordinating times and representing multiple time zones to put all of this research together. A few of us, 3 of us, will be presenting today. Some of us are in the meeting, and some of us had time conflicts and couldn't be here, but we all have contributed to this work. We'd also like to thank our mentor, Dr. Surajit Barma, and then also those who reviewed and edited and provided some advice for our mini publication. And then finally, just all of the CMA organizers, the professors and experts who created the courses and the resources that we've used in our own research, as well as this project as well. The volunteers, our TAs, and as well our RAs. Okay, so let's start by looking at the region specifically, and then some reasons why we decided to focus in on the Juba Shabelle River Basin. So it's located in Eastern Africa, and it's a pretty large area. It's around 729,000 square kilometers, while still being small enough that we can really focus on the regional hydrodynamics in the area. Additionally, there's a lot of rainfall that occurs along the mountain regions with less along the borders. And it's a densely populated area in Eastern Africa with around 30 million people relying a lot on these river systems and tributaries for agriculture, for food security, and just for a variety of reasons, making it a very, very important region to understand and to study. So these river basins are also shared by Ethiopia, Kenya, and Somalia. They don't each share the exact same portion of the river basins and the tributaries, so that also adds to some of the complexity in this area. Okay, so now that we've talked about the region that we're looking at and focusing on, we're going to move to Jimena, who's going to talk about the data we used and the methods that we went through in order to answer our research questions.
Yeah, hi everyone. Yeah, in the part of the data, we wanted also to have representative long-term quantifications on the variables of the interest. This can be achieved with the relatively new NOAA's climate data record for NDVI derivative, AVHRR and BIRS, latest versions, consisting of daily data and enhanced spatial resolution are roughly 5 kilometers. We could notice that by the year of 2040, both sensors concatenate to apparently for a single, not interrupted NDVI world series. To have more realistic approach, we made use of the data's quality assessment, which indicates of each grid point if it has technically noise or mainly if it is affected by cloud presence or its shadows. In the parts of the methods, we combine the data to check homogeneous metadata to future array operations. and clip the station using a vector file of our study area so the data weighs less and can be treated locally. The raw daily data has high variability due to seasonal and regional meteorological behaviors, and we assume a more conservative behavior for ground textures, meaning that one can expect to have the same vegetation stay throughout a month. This gives us an opportunity to detect cloud monthly patterns in the region by insistence and the NDVI representative monthly value, which will be constructed by a no cloud coverage, a single available day against all the other days of the month that we find. This happens mostly on the spring and summer season. Now, this will keep the methodology and results.
Right. Yes, for the last part of the methods, we actually suspect that as dense vegetation is placed under cloud activity, rain, a monthly regional NDVI can be false by the lack of data the clouds will generate. So in assessing the association of the percentage of lost pixels per month as the independent variable with its respective regional NDVI, which is to be imperfect as it comes from considerable lack of pixels, we used a linear regression model. And finally, a long-term composite is constructed, despite all, with all available data to know the distribution of the NDVI. So for the results, we have this figure that shows the intermonthly variation of monthly mean NDVI and percentage of lost pixels by insistence of clouds shown in bars. The time series has the NDVI fixed in between 0 and .6, NDVI dimensionless value, while the bars are set between 0 and 50% of the area with missing values. Both variables act seasonally. More pixels are lost in the rainy season of boreal spring and summer, April to September, due to cloud coverage. It is evident that also from 2014, the values in each variable contrast in magnitude. The NDVI values ranges in the AVHRR period from .2 to .4 through all the period, and it changes with the beers to .25 to .45. So the sensor properties make the data less prone to present cloud coverage, keeping the seasonal behavior. I mean, talking about the PIRS sensor. Next slide, please. The two peaks, if we see more broad as a subset of the period, we can notice two peaks that correspond to other works done on East Africa and using AVHRR, but with a wider resolution and short time resolution also. But the two peaks are consistent, and nevertheless, the second rain season in our work is underestimated, probably due to lost data. The next slide shows the accumulation of missing pixels over the long-term series by month to avoid the cloud patterns in a spatial perspective, right? Like for a month, how much cloud it will be through the years present. It is probably as so much as accounting of the lost pixels in the monthly resolution. So constant cloud coverage, missing pixels concentrates in the high region of the study area, about 1,000 meters above sea level, in the top left side of the basin, and in the low region near the Indian Ocean in the Vanadis coast. So there are two important regions which activates in 2 times through the year. And the gray areas will represent the hot the pixels had 16 to 66% of the long-term data gone by cloud coverage. It is more probable to be on the rain states in this part of a year, right? And the black areas shown an important void of values, which is consistent despite the monthly reductions that represent the most probable places for rain activity, dense, higher NDVI. And correlation between was expected to be negative. This figure shows a resulting negative correlation between the NDVI and so this says that the NDVI is more likely to be found, higher NDVI is more likely to be found in a complete array of monthly values. In low NDVI values, as the lost pixels increase, when the NDVI, when we have more pixels lost, it depends on the year, we will see a reduction on the NDVI that is nearly that one in magnitude, which is kind of big for a dimension that goes from 0 to 1. And so this could explain maybe also the decreased NDVI values between summer and autumn, corresponding to the transition between the length of both growing seasons, which rests as an average to the lowest and highest NDVI in other works. Ours, this transition goes like underestimated, goes very low. And lastly, we have anyway the composition of the 30-year average monthly NDVI over the area of study. We take advantage of elevation dashed lines to see the association with the geography also and the concentration of forest lands of the Rift Valley, if I am not mistaken. So next slide, please. I think yes, I added this. I also wanted to share the 500 meters above sea level. We can see that the lowest NDVI values correspond to the valleys and to the areas where we haven't done a demographic study about the area, but there's more people likely to be found in these concentrations of that two less NDVI magnitude. And the mainly predominant vegetation cover types in the Yuba-Shabelle Basin are grasslands, woodlands, agricultural lands that correspond between that 2 and that 6 NDVI dimensionless value. So for conclusions, we have that meaningful impacts of cloud activity over the region affects the availability of surface reflectance values. There is a great difference in BIRS version 1 data against its predecessor, ABHRR version 5. The cloud patterns are well defined and more studies can be conducted considering this methodological factor, and not only for lost data assessment, but for synoptic behavior of rain and radiation schemes inside the basin. Ulterior works should aim to have a long-term deductions. Most works found on the east region are about just 10 or 15 years, and is data from before the 90s. So the works we think that should indicate restrictions on the data to be more exact on the impacts of climatic events such as El Niño Southern Oscillation, which is something we are interested on to complete more, to deepen into this work. So that's it. Thank you.
Thanks team. That team name is something that I would never try to pronounce. Right. Any questions? You can raise your hands or put it in the chat. I can start with my question. So when you're looking at the cloud, looks like you're using basically the cloud, the quality flag from the from the climate data records data you're already using from Reflectance and NDVI. Have you tried to look at the cloud climate data records that NOAA also puts out? There's few cloud climate data records. So that provides not just cloud existence, but the fraction as well as the probability of the cloud. That may give you a little bit more information than just a quality flag that you have here.
So for that kind of alternative, we can look for data that is complete in the resolution and the space and the time and the space resolutions, but we haven't found one that suits. Actually, I found the Beta 5 has a 25 kilometers resolution. It has a cloud pixels, the degree and the percentage of cloud presence, and it has long-term data. Some satellites can help us, but they have even wider space resolutions, and they actually also have low space resolutions, time resolutions.
Oh yeah, there's one called Patmos. You might be interested in taking a look at it. It's a little bit coarser resolution than if it's aggregated to 0.1 degree, but still that's some information. If you look at the region, it's not a bad alternative to look at the fraction and from the cloud.
Thank you.
Yes, Isla?
Yeah, I was just wondering, so you ended with the AVHRR in 2013 and moved on to VIIRS in 2014. Did AVHRR actually end in 2013? Or was there any period of overlap that you could use to kind of try and compare them?
Yeah, good question. No, actually, in the buckets of the NOAA's, it is very. You can see the exact line. December 2013 has the AVHRR in version 5, daily data from the 80s, I think, and then the 1st January 2014 it has the VIIRS, the VIIRS, and actually into Google Earth Engine, I also found that the AVHRR ends in the 2013. So we were not expecting to have different values. So we decided to have most of the calculations just for the longest data that we have from the AVHRR and leave the VIIRS sensor to other exploratory works.
Yeah, it's unfortunate. Even having a year of overlap, there would be some way to maybe kind of match them somehow, but yeah, I guess that's not possible.
Yeah.
I can speak to that question since the data is put out by us. And AVHR quality has degraded to a point that we should not use it after 2014. There used to be AVHR data after 2014, but the quality is not good enough. So that has been removed from archive and continued with the VIIRS as a sensor. They're trying to do the sensitivity analysis based on the VIIRS and the AVHR data. From developer side, that from NASA, they have been doing the calibration between the two sensors.
Okay. Is there any work being done to try and see how to combine those two records in a way to have a long-term consistent record?
Yep. So it's the data put out under the same product. So they are considered the same product. You're gonna see some of the inconsistency in I would not say quality, but the sensitivity of the sensor itself, because VIIRS has much higher sensitivity to some of the signals you see from the surface and the noosphere, while for AVHR as an older sensor, the sensitivity to some of the signals is less optimal for comparing to the VIIRS. So it's the artifact we have to live with to some extent.
Okay, so I guess that's what they showed, is that jump is kind of something we have to live with. Yeah. Thanks.
Yeah, it's the the curse of the technology advancement.
Yeah.
Any other
Thank
questions?
you.
I guess one more question I have is that what would you think for your next step for this project? Is things like you're right now looking at the clouds and NDVI values. Are you gonna try to move a little bit further down towards the application for agriculture, or this is the step that you're gonna stop here?
Well, I think we want to continue this because we understand the times the Climatematch team were giving us, and we were deeply interested in see the changes and don't believe in any data that has given us, but to inspect them and to have a more exact values for this. We thought that if we have lack of data, we could ponderate. We could create an array of ponderates between values and values, and if some regions increase, maybe we can expect the other regions in some places to increase also, and we can feel some loss of data. And that purpose will give us a chance to see the El Niño and Niña events, both in how much it changes in cloud activity and also in the NDVI, but this time with more complete data. Some interpolations. There are some techniques to feel the data, and we could explore this to have a better understanding of the vegetation dynamics and also apply this whole flow of work to other places for the decision makers.
Yeah, and I just want to add that I think we all are interested in kind of continuing with our future work, and it's also interesting how we started on one path and thought we kind of knew where we were going, and then this sort of kind of came up and we almost pivoted and we're like, okay, this is what we're going to address first. And so it's been kind of a fun journey working on this project. And then I think also looking at the NOAA data that you mentioned that we hadn't yet about the cloud fraction coverage, kind of comparing what we see with what we've used with that could also kind of be interesting as well.
Great. Any other thoughts from other team members on the call? If not, I'm going to turn it back to Isla to introduce our final presentation.
Okay.
Thank you.
Yeah. Thanks.